Hello dear all, greetings from Free Engineering School. Today we are going to discuss about nonlinear quasi-static analysis and followed by nonlinear quasi-static analysis Abaqus input file. So what is quasi-static analysis? By its definition, it is a simplified dynamic analysis method where loading conditions changes over a period of time. But inertial and damping forces are not considered in this quasi-static analysis. So before going to main quasi-static, just I put some picture or images which will understand the difference between the loading conditions like static, quasi-static, and how the dynamic will. So in the first image, you can see camel is taking tons of loads from a place to another. So it is having constant loading conditions. So you can see it as static loading. And in the quasi-static loading conditions, if you see the image, you can see a monkey is jumping from one branch to another branch of the tree. So each branch will influence different loading situations in this. So in the dynamic loading conditions, as you can see in the picture, that the horse will have a faster rate of speed, that the same way the loading will happen in the component with respect to time, even it is in a milliseconds as well. As I mentioned in the previous slide, quasi-static will help us to analyze the problems with time-dependent material response, for example creep or forming. Here I have just shown the deep drying process for generating the oil pan. It is having an assembly of die, punching machine, and blank sheet and blank holder. As impose the displacement through punching machine, you will get a defined oil plan as shown in below. And if you consider the force versus deflection, you will get a continuously varied forces with respect to the punching machine moves down. So this is the type of example which will comes under quasi-static analysis, where we'll neglect the inertia and the damping effect. For quasi-static analysis, Abaqus offers two solvers. One is implicit and another one is explicit solvers. These two solvers will play a major role, because in implicit solver it is due to high nonlinearity, the simulation will take more time as compared to explicit solvers. Here we'll give a amplitude curve with respect to time and will resolve the solution, but here it will we will directly impose the displacement or the force in order to get the completed deformed oil fan. So it will take much time as compared to explicit solvers. And quasi-static analysis can be used, as I mentioned here, we need to neglect the inertial forces, and it can be used in a linear or non-linear type as well. Here we'll discuss about the input file for non-linear quasi-static analysis. I have taken an example of a fitting process. The component 1 will comes and fit into component 2 with the imposed displacement of 5 mm. In the nodes and elements section, along with star nodes and star element sections, we are added star kinematic coupling which help us to impose the displacement. And in the section material and contact properties, as I mentioned, the solid sections are the two solid sections with the steel properties, and we'll have a material non-linearity as well. We have taken plastic material properties like yield and ultimate with respect to uh, percentage change in elongation. And we have given a surface interaction with the friction of 0.2 and contact pair interaction with respect to the friction, and we have created a surface to surface contact like a slave surface and the master surface. While creating the contact, we need to first take a slave surface and then master surface in the Abaqus. This is the thumb rule for selection of contacts. So in the step, we have mentioned the non-linear geometry to be S. So we'll consider the nonlinear geometric variation as well. And we have taken a static stabilization. Initially it will give some stabilization for solving our problem. So I will detail discuss about this, how the stabilization will work, because for structural analysis it is usually damping will be considered 0.5%. So I will discuss in detail this stabilization, how we can add it into different simulations. And coming to the boundary type, we are displacement type is displacement, and constrained all the degrees of freedom for the component to bottom side in all directions. But in the load node, I mentioned the load node is the one. This is the master node. We have imposed the 5 mm displacement in y direction. So load node we have imposed to 5 mm displacement in downward direction. So other all directions are fixed here. So it will try to impose the displacement when the solution starts, and it will give the reaction forces. I have printed the reaction forces to the DAT file, which will help us to give what is the reaction forces to complete this 5 mm gap. So in the output file, I have again extracted the total force and the reaction forces displacement as well. And the elemental output, I have taken the plastic strain, since I have considered the plasticization or non-linearity, plastic non-linearity, material non-linearity. So I have taken the plastic strain and the stress. So these are the main input file we'll consider to get the output. So that's all. So that's all for today's quasi-static non-linear study. Please write your comments or any suggestions. So we'll meet in the next session. Thank you.